Hey, all right. Um, we are going to do some light mechanical design in a second. Any minute now. Soon as this loads. Okay, this is going to be a silly one. Um, Behind me, you'll see a bike. That's a ledge. I'd like to hang my bike from that ledge. I'm going to design a frame to do that. I've already gotten started. Kind of sit here. This is using the tiny frame system I developed. So Tiny Frame is a modular framing system, and it's made of pieces that you can easily 3D print. And it lets you create things like this. Think of it as like PVC. These I keep in a box, and they're great because I can quickly pick them apart, assemble them, and then put them in the storage box like this. See? Like I said, just like PVC. And you join them with blocks like this. You just print a bunch of them, and you leave them around. And when you need them, like I do right now, you pull out the replaceable and reusable pieces, and then you design small custom components to make it work. And that's what I've done here. So we're actually going to go through and just design this thing real quick. Um, so it's really, I love this framing system. I initially designed it for a humanoid robot that I'm working on, just as a quick sort of tooling framing system replacement. Because you never know, you might need to hold just the torso, you might need to hold just the arm, and so being able to quickly rough in some design in CAD and then pull it apart is very cool. Um, so we're going to do that right now. Except we're going to do it to hang my bike. My wife, by the idea, hates this idea. She does not want this. As a matter of fact, you can't see it, but there's a closet to my right, which might be obstructed by this. So she might veto this, give her veto rights. But nevertheless, we want to design this because it's fun. So we're going to design this for fun. And she will veto it if she wants. And then we're going to, after this, after I finish this real quick, we're going to move on back to the part tumbler here. But this is just going to take 20, 30 minutes, hopefully, maybe an hour. Anyways. Okay, so I was just creating the mounting holes for this. So the way this works is these members will be in tension. The bike's going to hang from here. We will put these members in compression, and everything's going to be great. Actually, yeah, let me finish this detail, and then we'll get back to this. So I'm realizing I might need a little extra meat here, because I think this is not going to be strong enough, so I'm going to edit the sketch real quick. So I want this to have, I don't know, call it that. Just a little bit extra to reduce the likelihood of block pullout, shear failure, which I actually don't remember the name of specifically. I think it's block shear. It's the name of that failure mode. Essentially pulling this hole out. the part. Put some healthy fillets on this. We'll continue cooking. Okay. All right. This whole went away, so let's fix that. Okay. So now we have to terminate these. See if I can quickly do that. Ta-da. Okay. As a matter of fact, though, I think this is going to rotate a little bit because I'm realizing 3 members might not be enough. So I'm going to do that. And I move the distance, essentially, of one of these members. Okay. Make a copy and pull them in. Ooh, that's wrong. It's fine. Another translate. Hope the audio is good. Probably is. Or as good as it typically is. We'll add a 4th one here. And this will be the last member, so I'm going to just reinforce this. Actually, wait, we have to calculate this new angle. So, 1 second while we do that. Actually, honestly, I'm just gonna, there's no reason to get too into the weeds on this one, because we're gonna resolve the position of this when we get there, so I'm actually gonna just align this. Only faces of highlighted components. There we go. And then that out. Okay. Looks like it might be a little too long, but I'm okay with that. So now we're going to rotate this into position, and we're going to pick up pivot point, which is that. We're going to play with some angles here. 5 was a little too much. 4 seems to be almost right. Not quite. 3. 3's cooking. There we go. All right. And then now we have to develop this mount. Mounts to this. So the idea is this sits on the wall. All right, fix it. So this actually slides into the wall, like so. And then you use these tensioners, you twist them, and they engage the wall. That's the idea. So now we design our mating block, which honestly is going to be pretty much a copy of that. I wonder if we can just 180 that. Should be able to. Pull that onto the end of that tube. You gotta think of this as just like PVC pipe, but with CAD you can download. That's the way I'm thinking about it. Which there is no CAD for PVC. PVC is also not a structural thing. Actually, this is also not a structural thing, I should say. So, warning, this is not a structural thing. But in low risk environments, you're good. So I'm not hanging this over anyone, and I don't really care about the bike, so. Okay, let's move this back a bit. I'm just trying to cut this tube in a way that makes sense. Okay, and so now we're going to create this block that's going to mount this. And remember, this is going to be in tension. So what's the best way to model that? What are we thinking here? It's going to be a block. It's going to look like... does this work? I'm realizing I might have made a mistake here. That kind of works. Forgot to put... No, this works. We'll be fine. We'll be fine. Okay, so we need to put a block here. So we got to model this now. So we need a part that joins, essentially it's going to be this line here. I'm just going to draw something really ugly to start, just to show representationally what I'm trying to do. Give it some reasonable dimensions, 35, 35. And then we will snap a dimension from there. 15 sounds good. That's constrained. Okay, so what we're trying to do now is create first half of our mount. And then we're going to mirror that to the other side in a second, but yeah, and so that'll get mirrored to the other side, like so. And we're going to terminate this into this block. Ooh, that is not symmetric. Why is that not symmetric? Why did my mid plane come off? No, that's right. Okay. What did I break here? Something broke. It's fine. Okay, so we want to put our mounting block in here. So let's actually take a step back. Actually, no, we'll hold on to this. Let me create another sketch and then come in here and find the material we're going to take away. Looks good. We want to make that not go through our tube that we're trying to make. Okay. For the mount. Okay. So now we put in, actually no, we got to connect this. This is the mounting block. And we can turn that, so that's good. This can be fixed. So we have to find a way to get this terminated into this. So let's find an ugly way to do this. Actually, real quick, let's see what happens if we replace face here. Not the other way around. That's roughly acceptable. It's roughly acceptable. So actually, let's delete this mirror real quick while we work on one side. Pull that back, and then let's actually first isolate these. We pull that back, and then how about this? We extrude this just 1 millimeter. just to subtract this profile. But we keep the original, obviously, and that breaks. Does that break? Boolean operation failed. Oh, I see. This should have been a new body. Okay. Subtract and we keep the original. Now we have this profile contour. And while we're at it, let's actually clean this up a hair. Yeah, that's actually almost perfect. It's great. I want to try the loft command for a change, because I seldom take advantage of it. Okay, then we extrude this face out. Then we mirror. Then join, and then we're gonna try and loft this. This might be a little too small of a surface to do that, but give it a shot. And then let's actually clean this up a hair before we do that loft. We're actually going to go back to an isolate here in a second. That's going to be all right. Let's do we gotta loft this face onto this face, but we have to figure that face out first. So this isn't gonna work, but I'm just trying to show what we're trying to do. So if we do this, it bugs as it should. So what we'll do is we'll slice this in a way. We set a baseline that makes sense. We'll try the loft one more time. It also bugs. I think it's because we have this surface here. Maybe we have to make that circular. Maybe that'll work. This might work. Yep, there we go. Doesn't work exactly the way we wanted, but maybe that's okay. Let's actually pull this back a hair. Let's see if we can make this work. It's looking more real. What if we loft? Actually, let's join these real quick before we keep going. And clear history. It's slowing down a bit. Okay. Let's slice this and see if we can. Actually, we can just brute force, I think, chamfer this. That's probably what we want to do. We can work about lightening this. This was 11, do 11 on this side. Actually, let me just slice this down the middle so we don't keep having to duplicate our work. Let me just clean this up. Okay. This also needs to get cleaned. No. Can I replace face here? Nope. Okay. Looks better. All right, so we should be able to mirror this now. Join these. That should work. We should stiffen this up a bit. Not stiffen, strengthen this up a bit here. Because we don't have that cleanup there that we wanted. I don't know what that is, but looks like we're getting a little bit of overlap here. Okay. So we're now going to join these. Actually, before we join these two, I want to hollow this out. So I'm going to do my favorite thing, which is the shell tool. I'm going to pull this in and see what we can get out of this. Actually, I already have a variable set for this, so we'll try that. Cool. So that looks cool, but it is not injection molding manufacturable. And the reason for that is we have an overhang, and I'll show you. So if we look at this in section about this plane, right here, what this is saying is that when we try to, actually let me draw. When we actually try to insert the cavity, I mean the core here, it's going to happen from one plane, like this. And so we're actually going to intersect with this portion right there. If you don't have one of these and you're an engineer, I highly recommend reaching out to your contact at Protolabs and asking very nicely for one of these injection molding toys. It's a toy, but it's super useful because it shows you what all of the nomenclature is for the injection molding process, and actually helps you think through some of the injection molding steps. And so the way that this is currently drawn, we have our cavity, we have our core, and the core and the cavity join, and then you through the sprue, I think it's called the sprue, yeah, through the sprue inject your material. When you're done, you pull out this secondary core, like so, and then your part comes out. What I'm saying is this right now is a little too complicated. We will have to figure that out. Also, this is 3D printed, so you're thinking, well, why is he even talking about this? Skill issue. You should always design your parts as though they will be injection molded. A, because we can, and B, because it makes you a better engineer. And C, because if you ever want to mass produce it, you don't have to do a total redesign. So how would we do that? We have this weird angle. The answer is we have to draw the sketch, we have to pull a sketch, we have to draw a line that represents the insert line for our core, and then we'll have to fill this material in. That's the answer to that. And the way we can do this is to, there's our line. We actually, I think we just bring this material down. And I wonder if there's a way that we can just draw a plane on this, slice it, and see if we can mend it. So parallel to that face, we're going to go to this line and then slice this. And then it bugs out. Why are you bugging? It's because I think we have some tangency here. Yeah, it's because we have some tangency here. So I'm going to move it just a tiny bit, and this should unbug. It's not Shaper's fault, it's the Parasolid kernel's fault. Well, it's not just Parasolid, every kernel is bad at this. So, all right, so that's what our part is going to look like. That's probably okay. So how do we mend that? I think we do just a straight line. Another sketch here. Another straight line. Join it there, and we extrude that through. Ooh, we need to really extrude that through by first getting some lines that make sense. We can go back to a reasonable view so I'm not confusing you. So this was, what's the right view? Right view. Okay. Now we can extrude this. We'll do a symmetric and we'll pull it out. Do a new body. And then we'll get to slicing. If you hear jets in the background, it's because the Blue Angels are actually performing in Seattle this weekend and they're rehearsing. So apologies if the sound of freedom is deafening you. It's you know, probably also a skill issue. So what is this radius? 8. 8. Okay, and so now we'll slice this about the midplane. We'll mirror that over. I have to say, doing engineering with F-16s in the background is pretty cool. So before we mirror that over, let's clean up this as well. Honestly, I'm so, now that Shaper has slicing with a cylindrical, I just use it 5 times right now with a cylindrical surface. It's been such a game changer. I love it dearly. Okay, so now this is injection moldable, because when you insert your core this way, you'll be able to get that. Okay. Now, I think we're done. All of this material is redundant. If you look at the load path, this is intention. I'll draw on this. This is intention, and we will not want any of the material here essentially. So, and I can quickly get rid of that by just pulling a chamfer to clean that up. Oh, but there's something going on the inside, isn't there? Yeah. Oh well. Actually, not oh well. Let's fix that. So we'll chamfer that. Oh, we still have this injection issue here. All right, we're gonna run into thickness issues here, but we can deal with that later. Okay. 3, we need some radii on these too. Okay. Want some radii on these as well. Nope. We want this. Yep. This one as well. Okay. This might be a bridge too far. Oh, that's a bug. Gotta figure that out. I think we need to replace face on that though. Let's surround. Get a good view of that gap. We created some gap here we have to fix. Okay. Just brute force that. Good enough. All right. So there is how I'm going to mount my bike. Join this. Fill it there. Okay. Cool. So I'm going to go build that and then see what happens. Which one screws through here? I'll deal with that later. I just need to make sure I have at least 25mm-ish M4s. This bugged. I wonder what happened there. It's fine, it's symmetric, so I can just mirror that. Cool. All right. Easy peasy. Actually, first I want to, this looks a little weak. The chamfers. Said 11. Yep. Okay. There it is. This looks wrong, so we're going to unwrong this. Still looks very wrong, but don't know how to make that any better than it currently is. Just leave it there. It's just kind of ugly, but it's actually really ugly. Why is that so ugly? And why is that so ugly? I should just delete this. Yeah. All right, I'm gonna de-ugly this. So my thinnest material is right there. My thinnest material condition, I should say. So then we'll make this tangent and then use this to slice. Why did that bug? I don't know. Okay. We can just leave that pretty much empty, I think. No big deal. Then here, we fix this, doing the same method. Make this some arbitrary angle. Okay. Still ugly, but less ugly. Okay. Cool. Right. So, I'm going to oversize these holes just a hair for clearance. And then need to offset these faces so this can actually fit on. Right now it's wall to wall. So we'll just do a negative 100 micron offset, and I've already got it gapped up top here. Yeah, we're good there. So that should fit. 200 microns clearance is plenty. Okay. That should be done. What am I forgetting here? Let's just do a quick calc real quick. I actually don't know what the load is going to be here. I want to know what it is. So we'll get some geometry here. Calcs. Is there a way to snap center on this? Because it doesn't really matter. Call that 270. Alright, so this is, draw this out here. We have a triangle. This is 270. This is 970. And then this is 1000. Very convenient. Wish you could see this. They've actually got the formation going right now. It's pretty sweet. And they're doing it over the city, which is kind of scary. All right. So we have our load P. So let's do the calc on this. So this is technically just a reaction force here. And this will be the counteraction force, R2. And there's no vertical component here. There's only a vertical component here. Call it RY2. So some of the forces about Y, it's pretty simple. RY2 is equal to P. So that one's pretty easy. Some of the forces about X is 0 is, so really, yeah, so R1 is equal to R2. And to figure out R1 and R2, we have to, essentially, we sum the moments about, we'll pick a point here, A. So some of the moments about A is equal to P, it's 970 P, because it's 970 from here to here. And moment is equal to force times distance, which is D is this, and force is this. I should say this real quick, that P is just the weight of the bike. This is a safety factor. I'll make this more legible. P is equal to R1 is equal to R2. Actually, let's do the distance. 270 times R2. Yeah. It's pretty simple, huh? So R1 is equal to R2, which is equal to 970 times P divided by 270. So R2 is equal to R1, which is equal to what we just wrote out, which is 970 divided by 270, which is 3.6 times P. And what is the weight of a bicycle? 20 pounds. Mine's a lightweight bike, so call it 20 pounds. Which is equal to 3.6 times 20. So R1 and R2 is equal to 3.6 times 20, 72 pounds. Actually, just make this clear. So 72 pounds. These should all be pinned. And this is actually not acting pinned, which is a problem. So we should actually get rid of this bolt here to make that act as though it's pinned. That sounds smart. I'll build and test. How about that? Then I'll see. Okay. 72 pounds of load. Can this take 72 pounds? Let's find out. Yes. That's a joke, by the way. That is not engineering sanctioning or advice that the system can do. Take 70 pounds. Okay. So that's that. I'll go make this later. Back to the tumbler. So I am liking the new diameter. Oh, before I forget, I tried something. Check this out. This is a part that I nested in another part and printed on top of. So I can actually slide this out, I think. This looked like this. So I printed the bottom block, and then I set this on top, and then I printed it, and it actually enclosed it. I wanted to try this because people have been talking about putting nuts into parts and then continuing to print. I really like that idea, and I've managed to do it. You just add a pause. So that's very exciting. Very cool. All right. Anyways, back to the tumbler. Let's make a copy. We are on mini B, and we are on version A of that right now. That's crazy. I used to work in San Diego, and they have a big military base there. And it was always funny being on a call and you hear just F-22s just roaring by. Made it tough to pay attention. All right. So what do we have left? Diameter of the barrel we need to fix. So nothing in the design changes in the bearing, and I do think we end up changing the diameter of this potentially. Depends on the latching mechanism, so we'll leave that for now and see if we have to adjust the frame. Okay. So we're gonna have to add a not a crease, an overlap here. So first, let's just clean this up and join it. So hem nuts in the wrong place. Gotta fix that. Crazy that you can fly F-16s feet away from each other over a city like that. All right, and let's save this. Actually, we want this mid-plane, I think. Where'd mid-plane barrel go? I guess this is the mid-plane, so I don't really care. Yeah, we don't really care. We'll save mid-plane frame though. Get this hardware patterned out. Okay. What else? We have to do the hatch. We said that was 135 degrees. That's 135 divided by 2. And then we'll mirror that to the other side. Slice this. And actually, we also want to just put some arbitrary distance off here. Call it 30 millimeters away from the end. That'll be our hatch. Okay, here's our hatch. Let's pull this back over. See if we can just copy this in. Why is that bugging? Okay, so there's our geometry for that. And then we want to pull down that strap again, but we'll do that in a second. So does this, oh, we want to get the length right too. And actually that length, it was getting pretty close to the maximum dimensions we were allowed for this. So we should investigate that. So we're looking for maximum material. We were using stainless 304 at 30 thou thickness. So the customs can go a little bit bigger, but I think it was that 30 inches that we were worried about. So right now we are at 30 times 25.4. So we can do 760 millimeters total. We are at, oh, we got plenty here. Yeah, we're, oh, but you know what? The length. The circumference of a circle is 2 pi d, or no, it's pi d. So we're at I think we said 250. So we're getting close. we're at 250. So that's 785. We actually can. I mean, technically we can. We're gonna have to get a custom quote maybe. Is there a workaround on that? It's annoying. We're just off too. We're just off by like 20 mil by 1 inch. You know, that's going to vary from vendor to vendor. So it's probably not worth chasing down getting the correct instant quote set up, or getting the instant quote thing avoided. So let's see if they have stainless. 304. I actually have. Wait, I thought we were. Huh. Funny, they've actually got different thicknesses. 30 gauge, 30 thou, and they've got 24 and 36. I actually want 24. Interesting. It's definitely thicker. Centrifugal tumbling. Would you look at that? That's what we're doing. Doesn't say maximum size. Doesn't say. All right. They can still make it. It will just be suboptimal. That's okay. We actually want, we'll slice that in a second. So this will be the hatch. Move this out of the way. to create that overlap now, so I'm just working on that overlap. All right. All right, what I'm trying to do is create an overlap here. I don't know if I have a good view of this from before we made the changes to it. Maybe we do. I can show you what I'm talking about. Yeah, you can see I had this overlap. Oh, that's right. We tried, we actually didn't brute force this. I remember now. This was a smarter way of doing it. And so we were worried about this gap, and I actually think we're okay with that gap. We're going to find out if it's an issue, but I'm okay with that gap. So we don't need to do an overlap. Phenomenal. Glad we looked at that. So how did we do this? We split that. We just revolve. Oh, what did we do here? I think I just did it the wrong way. Let me actually walk myself back a bit. See where we went wrong. Yeah, let's pull ourselves all the way back here and do an offset face. Actually, that's perfect right there. Great. We'll pull this back just enough to trick the brep kernel into thinking that this is not the same face. Ah, it thinks it's the same face. I wasn't able to trick the brep kernel because it can see to 1 micron. Can you see to 10 micron? No, you can't. I win. Aha. Okay. So let's copy this geometry over. How are we going to do that? Actually, what if we just mirror it? No. Okay. And so, how are we going to model this? Some more brute forcing, maybe? Brute forcing this. So what is the thickness of this? So let's get an angle. Maybe that'll be faster. Straight. We're just going to go off of feelings here. We're going to feel this out. Seems like too much. Seems like almost it. That seems just right. It's breaking, so let's, I think we have to add a cut relief there. I think we do. Hmm. That was wrong. Another way we can do this is to just pull this face down, I think. What do we bring that to? That gives us issues. And we're going to be careful with edge distance here, but essentially we can be a millimeter between these two edges, I think. So we're at 3.5, we can buy ourselves another -1, I think. Though we might need a little bit more. That edge distance is getting pretty bad. 1.45. Honestly, you know, it is what it is. Actually, I think I know a better way to fix this. I'm gonna offset this. Some number 3. Yeah. Slice this. And then we'll bring this back up. Makes you feel a little bit better. And actually, we'll instead of 3, we'll make that 2. See if that fillet breaks. I think those fillets are going to break. They didn't. Good for us. Okay. Before we go back to those fillets, let's see if we can fix this. There's a little bit more room here. Blend's not possible. Try this. Get to the point right before these blends and see if we can fix this. That looks hideous. That looks awful. I don't know why, but I don't have a better solution right now, so you have to live with it. Good enough. Join. Actually, we need a cutting relief here too. How do we? Can we just mirror this? I don't think we can, but I'm gonna try. Actually, not mirror. I'm gonna try and rotate this. I don't think it's gonna work, but I've been having really good luck with nope, didn't work. There's a way to brute force this, which I'll show you. I'm going to, oh, this joint, I have to offset that a hair. So the way I can brute force this is to just copy this geometry over and then rotate it and extract essentially what I'm trying to get out of this. Which is this. Why did that work? I'm having not a great modeling day. This is going way slower than I would like. That's not very good. So I'm just gonna do this. Okay. So now I should be able to rotate this place. Almost. Almost. All right. It's more brute forcing. Sorry. Must do what we gotta do. So this is 2. A reminder, I'm doing this because I need a cutting relief. Okay. All right, getting there. Let's make a copy of this. We were at B before. Okay. All right. So we have to add back the hatch pivot, and then we will be in a better place. But that is it for today. So we'll have to do this tomorrow. All right. See you next time.